Folks, in this video, we're going to talk about reaction stoichiometry. In the previous video, we talked about how we balance chemical equations. As I mentioned, as chemists, our main job is to do chemical reactions. And when we present our chemical reactions, we use balanced chemical equations. But at the same time, when we do chemical reactions, we do need to calculate how much of the starting materials we need, how much of the product will be generated. In other words, we need to do calculations according to the ratio between the reactants and products. So this is called the reaction stoichiometry. It will guide us through our calculation. Let's take a look at this flow chart. This flow chart is going to be the basic procedures that we are going to follow when we do stoichiometry calculation. So for instance, if you have a balanced chemical equation, and if you want to calculate how much of the mass, how much of the B, or the mass of the B from mass of A, you need to calculate the mole number of A first, and then calculate the mole number of B, and then calculate the mass of B. All right, so these are the intermediate calculation targets. But how about those arrows? What kind of equipment or what kind of tools that we need to have to do those kind of intermediate calculation? All right, now let me label that. For the first arrow here, if you want to calculate the mole number of A, if you have mass of A, then you just need to use formula weight of A. Formula weight of A is the bridge. Now, between the amount of A in moles and the amount of B in moles, then that's going to be the molar ratio between the two. So it's going to be molar ratio between the two reagents. Where do we find out the molar ratio in the balanced equation? Well, that's going to be the coefficient in front of each reagent. So remember what we discussed in the previous video? We said that 1 mole of, this is a balanced equation. And now if you look at the coefficient, well, that means if you have 1 mole of magnesium hydroxide, that will react with the 2 mole of hydrochloric acid, generate 2 mole of water, and 1 mole of magnesium chloride. So that's 1, 2, 2, 1 is the molar ratio among those 4 reagents. Now, if you know the mole number of B and you want to find out the mass of B, then formula weight or formula mass, it depends on which one you prefer. We talked about the formula weight, formula mass in chapter 4, the last topic of chapter 4. If you don't know what that is, just go ahead and review that. Formula weight of B. Now we are ready to do some calculations. Let's take a look at this question. What mass of hydrochloric acid in grams is neutralized by a dose of milk of magnesia containing 3.26 gram of magnesium hydroxide? Let's do some initial analysis of this problem. That means that, well, by the way, this hydrochloric acid is neutralized by the milk of magnesia. Well, if you have acid flood problem in your stomach, you know that the liquid, the solution in our stomach is hydrochloric acid. So if you have acid reflux problem in your stomach, sometimes doctor will give you prescription of milk magnesia, and you can buy that from grocery store. So you can just drink that, and the magnesium hydroxide in magnesia will react with hydrochloric acid, so that will give you a little bit better feeling. The acid will be neutralized. So you have less acid in your stomach, so that will partially solve the acid reflux problem. All right, now, well, this problem tells you that you have 3.26 gram of magnesium hydroxide, it asks you to calculate how many gram of hydrochloric acid that you need to neutralize this much of magnesium hydroxide. So we are talking about these two compounds, okay? All right, how do we do the calculation? Follow the charts, okay? Apparently A here would be the magnesium hydroxide, B here would be hydrochloric acid. All right, so let's just follow the chart. Mass of magnesium hydroxide, it's going to be 3.26 gram. You want to convert the mass of magnesium hydroxide to mole number of magnesium hydroxide by using formula weight of magnesium hydroxide. Say, use this carefully. Gram should be at the bottom, mole should be on top. Okay. Do you happen to remember how we calculate the molar mass or formula weights of a compound? Okay. I hope you still remember that. Again, if you don't remember, go ahead and review the molar mass topic in chapter 4. According to my calculation, formula weights of magnesium hydroxide, I'll write it here. Okay, I expect you know how we calculate that. Of MgOH2, that is 58.32 gram per mole. Okay, now with this information, when you set up the equation to convert 3.26 gram to mole, then 58.32 should be at the bottom and 1 mole on top. All right, so by having this, we finish this. Okay, now our next intermediate calculation goal is the amount of hydrochloric acid in mole. Now we use molar ratio. Okay. I'll write it here, 3.26 magnesium hydroxide. Okay, I'll write the formula of those compounds to just let you see my calculation better. You don't have to write that when you do the calculation, okay? All right, now the molar ratio between the magnesium hydroxide and hydrochloric acid is 1 mole of magnesium hydroxide versus 2 mole of hydrochloric acid. All right, so now how do we do that? So apparently that since you have mole number of magnesium hydroxide on top, therefore for the molar ratio between the two compounds, you should have 2 mole of magnesium hydroxide at the bottom, right? So you can cancel that in this case, okay? Now, 2 mole of magnesium hydroxide versus 2, oh, sorry, it's going to be 1 mole, okay? My bad. 1 mole. And then 2 mole of hydrochloric acid on top, okay? All right, now, when you set up the equation here like this, the calculation results will be the mole number of hydrochloric acid. Now the last step of the calculation is to find out the mass of hydrochloric acid by using formula weight of hydrochloric acid. Okay, so that's going to be times the mole number of, remember, if you consider a unit, right now gram has been cancelled. This mole of magnesium hydroxide has been cancelled. And now, so this part will give you the mole number of hydrochloric acid. So in order to get the mass, the mole number of hydrochloric acid should be at the bottom. Okay, and the gram hydrochloric acid. Formula weight of hydrochloric acid, okay, is going to be, I'll write it here, formula weight of hydrochloric acid, that is 36.46 gram per mole. Okay, so 1 mole of hydrochloric acid is 36.46 gram of hydrochloric acid. All right, okay, so now you can see that you can further cancel the mole number of hydrochloric acid. The final unit would be gram of hydrochloric acid. Okay, do the calculation carefully, and my calculation shows me it's 4.0 8 gram of hydrochloric acid. 3 significant figures, okay, because you started from this 3 significant figures. This is how we do stoichiometry calculation according to a balanced chemical equation. Follow this chart, okay. In this particular problem, we are going from your left side to right side, and we can do the question on the opposite direction, okay. So it would be the same. All right. Let me know if you have any questions.